right, geometry, we are in Unit 6, Lesson 15, Weighted Averages. So let's warm up. For the questions in this activity, use the coordinate grid if it's helpful for you. So what is the midpoint of the segment connecting 1, 2 and 5, 2? So that one isn't too bad because it's a straight line horizontal, so the midpoint would be right there. The graph was sort of helpful for me, but if we can do 1 plus 5 divide by 2, that gives us 6 over 2, which is 3, and 2 plus 2 over 2, which is 4 divided by 2, which is still 2. So there we go, 3, 2. We could do it mathematically or graphically. Now how about 5, 2 and 5, 10? So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. That is 5, 6. So graphically that's cool. Or I can add the x's together and divide by 2. And add the y's together and divide by 2. So that gives me 10 halves, which is 5, and 12 halves, which is 6. Same thing mathematically. This next one, over 1 up 2, we're going to go blue. And over 5 up 10. Right, this one not quite as easy. I'm trying to get the midpoint of a diagonal line. So graphically is not so helpful, but I know mathematically I can go 1 plus 5 over 2, which is 6 over 2, which is 3, and 2 plus 10 over 2, which is 12 over 2, which is 6. Let's graph it and make sure. Over 3 up 6. That's on the line. So cool, we got it. All right, let's move on. We have a few copies of this particular slide because it's pretty crowded, so I'm assuming I'll be able to do a few of the answers and then move on to the next page, do a few more, etc., etc. So here we find the point that partitions a segment in a given ratio. Okay, so we're breaking a segment into a given ratio, and there's going to be a point that does that for us. In the warm-up, we broke things into equal pieces, into 2 equal pieces. In this, we're going to break it up into not equal pieces, into a given ratio. So first, I'm going to zoom in so we just see this one. I'm going to look at just that images for launch. What point would partition segment AB into a 1 to 2 ratio? That is, if we made that the point that broke the segments C, we want to say that the length of AC compared to the length of CB would be 1 to 2, okay? So let's think about that for a second. So if we did that, like, how many segments do we need total? We need 3 separate segments where the length of segment AC is only 1 and the length of segment CB is 2. So this whole length is 12. If I break that into 3 equal pieces, those would be my 3 equal pieces. So if I put segment C here, the length here is 4, and the length here is 8. And if I simplified that, I would get 1 to 2, or 4 to 8, okay? Pretty cool. All right, let's move on. So now if I zoom in on the problem at hand, point A has coordinates 2, 4. Point B has coordinates 8, 1. We need to find the point that partitions segment AB in a 2 to 1 ratio. So we need to split that segment up into 3 equal pieces, right? This one isn't so difficult. If I look at segment AB, I can see that that's 1 piece, that's 2 pieces, that's 3 pieces, and they're all equal because that's a slope. Okay, we're actually going to do, let's do it this way, a rise of 1, run of 2, rise of 1, run of 2, rise of 1, run of 2. So that right there splits it into 3 equal pieces. Now we want, we're going to break it into a 2-to-1 ratio. So we're going to make C here, and this distance is going to be 2, and that distance is going to be 1. So we want C to be the ordered pair over 6 up 2. Find the point that partitions, so we're going to say C is 6, 2. All right, now let's calculate 1/3 times A plus 2/3 times B. What does that mean? All right, I'm going to work up here. Number 2. C equals 1/3 times A plus 2/3 times B. All right, so if I replace A with the ordered pair for A and B with the ordered pair for B, I'm just going to do a little distribution to that ordered pair, which is really strange, but it's okay. I'm going to distribute the 1/3 to the 2, so 1/3 times 2 is 2/3, and 1/3 times 4 is 4/3. And I'm going to add that to 2/3 times 8, so 2 times 8 is 16, and 2/3 times 1 is 2/3. Now I'm going to collect like terms in a strange way. Those are my x coordinates. 2/3 plus 16/3 is 18/3. Then I have my y coordinates. 4/3 plus 2/3 is 6/3. And then I'm going to simplify. 18 divided by 3 is 6. 6 divided by 3 is 2. So mathematically, we can get the answer also, right? So the answer to number 1 is 6, 2, and the answer to number 2 is 6, 2. If you can't see it graphically, you can find the answer algebraically also, okay? All right, let's look at, let me get a new screen so we can try number 4. So if we look at question number 4, it says for 2 new points K and L, write an expression for the point that partitions segment KL into a 3-to-1 ratio. Now these are just 2 points. We don't know what they are, we just need to write an expression for them. So I'm going to say KL, let's call it M, equals, and we need to go to a 3-to-1 ratio. 3 plus 1 is 4, so we need to break that segment up into 4 equal pieces. And we want the K term to be 1/4 of the way down, and the L to be 3/4 of the way. That would be our expression for the ordered pair we're calling M. Pause for a second. Let me change to a blue pen, and let's look at number 2 again. Okay, we were breaking AB into a 2-to-1 ratio. That means if I add 2 plus 1, that's 3. So I've got 3 equal pieces. The first one is going to be the ratio of 2. So how much is remaining is what we want to think about again. So I've got 1/3 remaining. And then the one side of the ratio, how much is remaining, would be the rest of it, 2/3. All right, it's the same with KL. Let's go to a green pen. 3-to-1 ratio, if I add those together, I get 4. The left side of it, I guess I could call it, if I'm going from K to L. The left side of it, like if it's a 3-to-1 ratio, the 3, what's remaining? That'd be 1. And the L side of the ratio, if that ratio is the 1, what's remaining? That would be 3. Okay, maybe that'll help us remember it a little bit. Okay, push pause and think about that again if you'd like to. It'll be all right. The last thing I'm going to do is looking at the AB again. Let's look at numbers 1 and 2 with this drawing again, just to explain it in another different way, sorry. If we're doing that 2-to-1 ratio, I need to split it into 3 equal pieces, and this was the number we came up with. I could also set up similar triangles with that, right? So 8, 6, and 2, similar triangles to try to figure out the distance from 2 to 8 is 6. I need 3 separate pieces, so each piece is going to be 2. Okay, so the distance from 2 to 8 is 6 units. 1, 2, 3, 4, 5, 6. A 2-to-1 ratio means I need 3 equal pieces, 3 equal pieces. So if I divide the distance from 2 to 8 into 3 equal pieces right here, I need 2 units per equal pieces. So 1, 2, 1, 2, 1, 2. Those are my equal pieces. 2 units apiece. Okay. All right, let's do something else. All right, so here, here's quadrilateral ABCD. ABCD. That's hilarious because I was always taught to name them in this order, clockwise, but we are definitely going counterclockwise, ABCD. Find the point that partitions segment AB, so we're working on this segment, in a 1 to 4 ratio. So 1 to 4, how many total pieces are there with a 1 to 4 ratio? 1 plus 4 is 5 total pieces. Okay, so this isn't going to be quite as simple because if I count from A to B, I have 1, 2, 3, 4 pieces. Bummer. So like I said, I can't just count and divide for segment AB because it's not that simple. So I'm going to set up that equation, that formula that we worked on in the last section. What do they call it? They said expression. Sorry, that word eludes me sometimes. So if I set this up, let's plug in my ordered pairs. And you can use a calculator because we all love fractions, right? So A is 2, 3, and B is 6, 3. So if I distribute that fraction, I get 8/5, 12/5. See, I multiply across the top and the bottom. So 4 times 2 is 8, and the 5 is times 1 because there's a 1 underneath the 2. 4 times 3 is 12 over 5. And I'm going to add that to 6/5 and 3/5. So let's add the x coordinates. 8 plus 6 is 14/5. And 12/5 and 3/5 is 15/5. Okay, I can't graph 14/5, so I'm going to put that into decimal form. 2.8, comma 3. 2.8, comma 3 is right somewhere around there. All right, so let's try C prime, or D prime is next. So we're going to do that one in red. We did this one in black. Find the point that partitions AD in a 1 to 4 ratio. Again, 1 plus 4 is 5. So I want D prime to be 4/5 times A plus 1/5 times D. 4/5 times A we already have. 8/5, comma 12/5. And then 1/5 D. D is over 4 up 9. So that would be 4/5 and 9/5. So let's do the A coordinates. 8 plus 4 is 12. And 12 plus 9 is 21. Okay, that's not an easy thing to graph, so let me put that into decimal form. 12 divided by 5 is 2.4, and 21 divided by 5 is 4.2. So 2.4 and 4.2. That's icky, isn't it? All right, I assume you have those written down because I'm going to move my screen a little bit so I can keep on going. Okay, number 3, we are going to do in green. And it says, find the point that partitions the segment AC in a 1:4 ratio. So again, you add those together and you get 5. And my A is not going to change. We're going to label that C prime. 4/5 times A plus 1/5 times C equals, we already did A, so oops, I've got 8/5, comma, 12/5. I had to go look it up. 12/5. And then C, it's 1/5 times, C is over 8 up 9. 1/5 times 8, 1/5 times 9. I'm adding that to this. Add the x coordinates, I get 8 plus 8 is 16/5, and 12 plus 9 is 21/5. So that's going to give me 3 point something, 3.2, and we just did 21/5. It was 4.2. Let's try to graph that. 3.2, 4.2. That would be C prime, D prime, and B prime. And if I drew in the quadrilateral, it would look something like that. Not bad. Is a B prime, C prime, D prime a dilation of ABC? Justify your answers. Yes, it's a 1/5 scale. Dilation. We all the angles are the same because our lines are parallel. Each one of these lines is parallel to the one that we shrunk it from. Like those are all parallel. These are all parallel. So all of our angles are holding. It's just a 1/5 dilation. Okay, our scale factor is 1/5. Our center is A, so it just scaled in. Cool. So as a little bit of a review, we were able to find the partitioned point if we could count it very easily. If not, we are now able to set up an equation or an expression to find the new point. All right, so if you're stuck, you can just go back and rewind and watch it one more time, or shoot me a text and I will be glad to help you. Okay, we can work through another example. All right, good job.